Dear students, welcome to the chemistry class. Today we are going to start the chapter 10 S block elements. As we completed the classification of elements, it's very easy for us to learn about the S block elements. And we have here P block elements also this year to learn. So we will start with the 10th lesson now. And as we know, we were learning S block elements, how we can define it as when the outermost electron enters the s orbital, it is said to be what s block elements. So how we can give the definition? The s block elements of the periodic table are those in which the last electron enters the outermost s orbital. So this is how we can define s block elements. And as the s orbital can accommodate only how many electrons? 2 electrons, and that also in opposite spin. If they are accommodating maximum 2 electrons, they should be in opposite spin. That two groups, that is group 1 and group 2, belong to the s block of the periodic table. This is the main thing. We know that there are 18 groups. Among the 18 groups, group 1 and 2 are said to be S block elements. Group 1 of the periodic table consists of the elements lithium, sodium, potassium, rubidium, cesium and francium, and they are collectively known as alkali metals. We know the things, but the introduction part is there, which we have to revise it again. So which are the elements of the first group? Lithium, sodium, potassium, rubidium, cesium and francium. Even though the hydrogen is kept in the first group elements area, we can't say it as alkali metal. So it's a it is separated from that first group. These are all so called because they form hydroxides on reaction with water, which are strongly alkaline in nature. Why these are said to be alkaline metals or alkali metals? Because they form hydroxides when they react with water, and they are very strongly alkaline in nature. So that's why the name is there, alkali metals for the first group elements. Now group 2 includes, or they consist of which all elements? Beryllium, magnesium, calcium, strontium, barium and radium. These are the elements of group 2. Beryllium, magnesium, calcium, strontium, barium and radium. And these elements, with the exception of beryllium, are commonly named as alkaline earth metals. So among the group 2 elements, except beryllium, we can name it as alkaline earth metals. And these are so called because their oxides and hydroxides are alkaline in nature. And these metal oxides are found in the earth's crust. That's why the name alkaline earth metals. So this is about the first group and the second group elements. Now when we see the periodic table, we can see these two. This is the full periodic table where we are having the left side, the first group and the second group, which is named as the S block elements. First group, lithium, sodium, potassium, rubidium, cesium and francium. Second group, beryllium, magnesium, calcium, strontium, barium and radium. And we have given the names alkali metals and alkaline earth metals. Now first we will see the group 1 elements, that is the alkali metals. And what about its electronic configuration? As we know, the general electronic configuration for the S block element is NS1 or 2. Here we are having the group 1, so we will be having only NS1. One electron only will be there in the outermost shell. Or in other words, we can say the general electronic configuration can be written as square bracket, inside that the nearest noble gas and then the outermost electron NS1 for the alkali metals. This is the other form of electronic configuration. The loosely held electron, that is the S electron in the outermost valence shell, makes them the most electropositive metal. Why? Because they are loosely bound, so they are easily lost from the atom. and it becomes a cation, and it is monovalent in nature because only one electron is there in the outermost shell, so it makes M plus ion. M is the any metal. Then they are never found in the free state in nature. Now, here is the electronic configuration of the first group or first group elements, that is lithium, sodium, potassium, rubidium, cesium and francium. Now you can see lithium Li, Na sodium, K potassium, rubidium Rb, Cs cesium and Fr francium. How we can write? For lithium 3 is the atomic number, so we will write 1s2, 2s1. Which is the outermost shell? 2s1. Now, the next one is sodium 1s2, 2s2, 2p6, 3s1. You can see here again which is the outermost shell? 3s1. So, every outermost shell will be having what? Only one electron, and that will be in the s orbital. That's why the s block name K. Now, potassium when you are writing, you will write 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Again, the last electron is in the 4s1. So you can see in the full order 2s1, 3s1, 4s1, 5s1, then comes 6s1, 7s1. So this is how we are writing what? The electronic configuration, general outer configuration. And here all we can notice that S is having only one electron in the outermost shell. And according to the period, it varies. Lithium belongs to the second period, that's why 2s1. 3s1, third period. 4s1, fourth period. Fifth period, sixth period, seventh period. Like that it goes on. So, according to the Aufbau principle, when we are writing this thing, you can write in other words the noble gas and then the outermost shell. So, for lithium, how we can write? 1s2. This 1s2 is for helium. So you can write square bracket inside that helium symbol He2s1. For sodium, how we can write? Nearest noble gas you can write, that is for neon. Inside the square bracket neon and then 3s1. Like that you can write for potassium also argon 4s1. So you can go with that form also. That's why in the starting we have written noble gas then NS1. So this is other form of electronic configuration. Now let's see the atomic and ionic radii for the first group elements or the alkali metals. They have the largest sizes in a particular period of the periodic table. With increase in atomic number, the atom becomes larger. The monovalent ions M plus, that is only one positive charge is there because one electron is lost, are smaller than the parent atom. This we have learned in the last or the previous chapter, that monovalent or the cations are smaller than the parent atom. The atomic and ionic radii of alkali metals increase on moving down the group. That is, they increase in size while going from lithium to cesium. Down it is going, it is increasing. And francium is a radioactive element. Next we will see the ionization enthalpy of the alkali metals. What is this ionization enthalpy or energy? The amount of energy required to remove an electron from the gaseous atom. That energy is termed as ionization enthalpy. And for the alkali metals, it is low and decreases down the group from lithium to cesium. So, considerably it is low and it decreases down the group. And what is the reason behind that one? Because of the increasing size, which overweighs the increasing nuclear charge, and the outermost electron is very well screened from the nuclear charge. This is why the decrease is there down the group from lithium to cesium. And the next heading is hydration enthalpy. What is this hydration enthalpy? Enthalpy means energy. So hydration means the water content is there. And what is that one? It is the energy released when 1 mole of a substance is dissolved in large amount of water. We call it as hydration enthalpy or energy. That means the energy released when 1 mole of a substance is dissolved in large amount of water. That much energy is said to be hydration enthalpy. And for the alkali metals or metal ions, it decreases with the increase in ionic size. Decreases with increase in the ionic size means we have the order for Li plus greater than Na plus greater than potassium plus greater than rubidium plus greater than cesium plus. This is the order. So there's a decrease in the hydration enthalpy. Decrease in the hydration enthalpy. That's why we say that lithium is having more hydration enthalpy. So Li plus has maximum degree of hydration, and for this reason the lithium salts are mostly what hydrated. They are usually found hydrated. Like the example is lithium chloride is available in the form LiCl 2H2O. There is the water content. 2H2O is along with this compound, that means it is hydrated lithium chloride. Now let's talk about the physical properties of the alkali metals. Usually these alkali metals are silvery white in color. They are soft and light metals. And because of their large size, these elements have low density, which increases down the group from lithium to cesium. But there's an exception, that is potassium is lighter than the sodium. The melting and the boiling points of alkali metals are low, and it is due to the metallic bonding, which is due to the presence of the single electron in them, or the outermost electron. The s orbital is having only one electron, which indicates the weak metallic bonding in them, and because of that the melting and the boiling points are very low in the case of alkali metals. Alkali metals impart color or characteristic color to an oxidizing flame. This is because the heat from the flame excites the outermost orbital electron to a higher energy level. That means from lower level to higher energy level, the excitation is there, and because of that one, the different colors we can see in the visible region. That means when the excited electron comes back to the ground state, there is emission of radiation, which is in the visible region of the spectrum, and we can see the different colors for the metal or metal ion. And here are some metals which gives or which imparts the different colors, and it is having some wavelength. You can see here lithium is having a crimson red color, and its wavelength is 670.8 nanometer. Sodium yellow in color and 589.2 nanometer. Potassium lilac or violet 766.5 nanometer. Rubidium reddish violet 780 nanometer. Cesium blue and 455.5 nanometer. This is about the flame and also the wavelength regarding the metal ions. And now in the lab we are doing the flame test for the cation. And how we are doing the cation is we are doing or we are taking some of the salt in a watch glass, and then 1 or 2 drops we pour concentrated HCl, and using a glass rod or a platinum wire we just mix the paste, or we make this as a paste, and take the paste with the glass rod or the platinum rod and platinum wire, and then show it in the non-luminous flame. When we see the color, we can identify which cation is present in the salt. Like it can be barium, it can be calcium, it can be strontium, and these three we are doing in the lab: barium, calcium, and strontium, which belongs to the second group. This is the first group elements which imparts these colors. That means for the S block elements, they impart some colors to the flame. Thank you. We will continue in the next session.